It's day 4 of our polygons or quadrilaterals unit. Got a little bit of both here. We're talking rectangles today. So let's jump right on into the facts that we should know about it. So first things first is that rectangles have every property of a parallelogram. All right? So those 3 little dots mean therefore. You've probably seen that in science class, but if not, that's what that means. Therefore, right, they have all parallelogram properties. So I'm just going to draw a little parallelogram and say properties. So let's write that in this first spot, which means the opposite sides are both parallel and congruent. So we can show parallel with the arrows and then single stripes and maybe double stripes for congruent. There's a lot going on there. Opposite angles are equal. So we know this is the same as this, and that guy is the same as that guy. Consecutive angles add up to 180. And then the last part, the diagonals bisect each other. So immediately, just by saying that rectangles are parallelograms, they have all of those properties. Beyond that, you also should know that, hey, rectangles have 90-degree angles at the corners. So all the angles are right angles. So you can show all 4 of those. So even though above we said opposite angles are equal, we can do better than that. We can say that they're all right angles or they're all 90 degrees, however you want to think of it. And then same thing, we said the diagonals bisect each other, but we can be more specific than that. The diagonals are actually congruent. And the good thing is they look congruent, because when you can't squish it to one side, then one diagonal can't get really short while the other one gets long. They stay the same length, right? So not only, let's throw some labels on here. Let's call this A, B, C, D, and we'll call that center point E. Not only is the full diagonal AC congruent to the full diagonal BD, but since they bisect each other, we also get all the little parts are congruent. So AE is congruent to BE, which is congruent to EC, which is congruent to ED or DE, however you want to say that. All right. The one last thing, and we might as well throw this in here because it's going to be helpful, is that with all those congruent parts, it also forms isosceles triangles, right? So like as a little hint here, like triangle AED is isosceles, which, okay, great. But that means you get congruent base angles. Right? So just as a little something to remember there, that if these are congruent, so are those guys. Right? Because we're going to see a whole bunch of algebra questions kind of build off of this. And if you can have those little details, then you can work them in here. Right? So on to the next page. Let's put some of this to good use. Whew. All right. It says, given that JK equals 50, oops, there we go. Just making sure you can see me, okay? JK equals 50, that is this, and JL is 86, so that full length is 86. All right, something that should be clearly stated in any question, it's kind of missed here, is that KLMJ is a rectangle. It's not a trick question. It is one, promise. All right. So when I ask you to find ML, well, opposite sides are congruent. So ML is just 50. Easy, done. When I ask you to find HM, Well, HM is just part of the diagonal. So since we know all those little itty bitty pieces are congruent, and if the full length there is 86, we can just take 86 and chop it in half. So 43 is what we should have for each of those little segments there. That's it on the first one. Number 2, find the measures of the numbered angles. Okay, well, we saw questions like this yesterday with parallelograms, sort of the same idea, except for this time, we know the 4 corners are 90, so it's a little bit more specific. But we can still use alternate interior angles and so on to kind of work in our benefit here. So if we look at one like angle 68 in this corner here, if I use this line and this line being parallel and I connect with the diagonal so that I kind of get that upside down N, 68 and its alternate interior right here also have to be equal. So that one's going to be 68. That helps because 5 is the other piece of that angle, and together they have to be 90. So if we do 90 minus 68, that's going to give us 22 degrees. So that means angle 5 has to be 22 degrees right there. Right? The other thing that we can kind of take advantage of is the fact that we have a little isosceles triangle right here. So these parts are all the same. So if I focus on this triangle on the side, if these two are the same, then the 2 base angles, I'll grab a different color, would be down here, angle 1, and then that 68-degree angle. So if those are my congruent base angles, then that makes angle 1 68. Easy, done. All right, based on that, keep using that isosceles triangle. I know that a triangle sum equals 180. And so we can do 68 plus 68 and then subtract it from 180 to get angle 2. So angle 2 is going to be 180 and then minus 68 plus 68. So let's double that. If we double 68, that'll give us 136. And then subtract 180, that'll give us 44. So this is 136. All right, so that's our angle 2 right there. So let's see. I've got a bunch of things written here. Angle 1 is 68. Angle 2 is now 44. All right, angle 3 is adjacent to angle 2, and it forms a straight line with it. So that means that angle 3 should be just 180 minus 44, which is going to bring us right back to 136. There's also something called the exterior angle theorem that we talked about before, that this is equal to the 2 remote interior angles. Well, there you go. Add them up. That's that one. All right, angle 4. Well, let's see. Angle 4, have we already done angle 4? Kind of, because if this is 68, its alternate interior would be here, which means this guy to be 22 down there, just like it was up above. So angle 4 is 22. And then angle 5, that is also 22 degrees. All right. You might have done that question in a slightly different order had you done it completely on your own, and that would be okay. Sometimes you just have to go with what do you see and then run with it. All right, the last one, if you don't recognize it, that's a Regents exam font, which you guys might not recognize, and that's okay. It's saying, as shown in the diagram of rectangle ABCD below, diagonals AC and BD intersect at E. So they're just clarifying the diagram. All right, AE is x plus 2. Cool. BD, so this whole thing, that whole thing is 4x minus 16. Find the length of AC. Okay, well, the fact that we know that all the parts are the same, that means that this whole diagonal AC would have to be x plus 2 here and x plus 2 there. So if we add those together, or we could effectively think of it as doubling it, AC has to be 2x plus 4. And AC is the same as BD. So let's set up that equation. So 2x plus 4 has to equal 4x minus 16, and then we can solve. So subtract that over. I'm going to add 16 in the same step to kind of cut down on my work here. That'll leave me with 2x here, 20 over here, and then we divide by 2. X comes out as 10. Now keep in mind, that's not what the question eventually asks for. It asks for the length of AC. So if you can do all that good work, don't forget to plug back in. AC now is equal to 2 times x plus 4. So my final answer there is 24. But notice how 10 was a choice. Regents exams love to do that. I won't fib. I sometimes do that to double check and make sure you're paying attention. But always going to see that number pop up. Make sure you fully finish the questions. All right. All of that was on rectangles. Let's talk about next, rhombus. All right. For this piece of it, the rhombus, we can kind of go quick with this first part, has all the parallelogram properties. Right? Sounds weird to write it this way, but rhombi, like plural, right, are parallelograms. Therefore, have all, I'm going to draw it, parallelogram properties. And I'm not going to list them again. I'll say see page, what page did we do it on? Page 15. All right. Or you can see any of the pages before that when we talked about parallelogram properties. All right. For this, beyond that, a rhombus, I always think of it as a squished square. And all I mean by that is all 4 sides are equal. So 1, 2, 3, 4. All 4 of them are equal. All right. When that happens, when the diagonals stay equal to, or excuse me, the sides stay equal to each other, the diagonals have some cool properties here in that they are perpendicular. Right? Which means, you know, they're forming 90 degrees at the center. So when you have this diagram here, let me slide that up a little bit so you can see better. That means 90, 90, 90, 90. All right. So you have 4 right little triangles right there. Okay. Last part. The diagonals, not only do they bisect each other, because that's a parallelogram property, but they bisect the angles at the corner. So I'm going to say that the diagonals bisect the corner angles. And then let's mark it in the picture so you know what I mean. So in the corner over here, this angle will be congruent to that one. And since opposite angles are congruent, those would be congruent too. All right. And then I can go to the other pair of opposite angles. This would be congruent to this guy. And then this would be congruent to that guy. Right. So with all that being said, we should be able to put these to use to solve some problems, right? The last little detail that we can add on, though, before we flip, is because we have these little triangles, and specifically little right triangles, we can also note that the angles in those right triangles obviously add to 180, but if one angle's 90 already, that means the other 2 angles are going to be complementary or add to 90, right? So I'm going to say the 2 acute angles in the right triangle add to 90 degrees. Or we would say those are complementary. All right. We got some practice. If at any point you need to pause, hit pause and keep going. Otherwise, flip it on over with me. This one, again, this is a Regents question. This is a great Regents question. It's got a lot of pieces to it, so it kind of hits everything that we need to talk about. It's saying in the diagram below, you have quadrilateral star, so STAR. It's a rhombus where the diagonals intersect. They're just clarifying what all these things are, and they're asking you to find SR RT and angle TAS. All right, if you look at the picture and take a second here, there's different variables. We've got X's in here, we've got Z's in here, we have Y's. So basically, you're going to have to solve for each of those to be able to solve for those three things that they want up here. I'm going to start with side RS, and if I look at side RS, all the sides of the rhombus are congruent. So these are all congruent, and the two that are labeled are those guys. So since we have all sides equal, or you can say all sides congruent, I'm going to set side SR equal to side ST. Let's do it. We get 8x minus 5 equals 3x plus 30, and then rearrange. If we subtract this over and add that, we're going to get 5x and then equals 35. X comes out to be 7. Whoops, I'm so sorry. I'm right off the page there. And then you can plug back in. So the first thing they asked you to find was SR. So SR, 8 times 7 minus 5. All right, here's your chance for mental math, or you can pick up your calculator. So 56 minus 5, it's going to be 51 there. All right, now I did all that work over here because now I'm going to break it up and go for the next variable. So we did X. Before we do the angle, I'd like to do the other segment. So I want to go after Z next. So if I look, Z in the picture is used to mark some of the diagonal pieces. Now the diagonals, they do bisect, but not all 4 pieces are the same. So the ones that would be the same here are SE and EA, and then RE and ET. So with that being said, use the 2 that are labeled. So if we can use the fact that the diagonals bisect, right, each other. I know I'm super shorthanding that, but just trying to get all my thoughts in there. We can take SE and set it equal to EA. So I'm going to slide up so I have a little more space here. SE is 3Z, EA is 4Z minus 8. So this is a quick one to solve. If we just subtract over 4Z, we get negative Z equals negative 8, which means if I divide by negative 1, Z will just come out as 8. All right. And so to find the length of RT, let's see, RT is that whole darn thing. We would have to plug into the only piece of it that we know, the 5Z plus 5. So let's find ET first. So 5 times 8 plus 5. So that's 40 plus 5 or 45. And then that means that RT is going to be 2 times that. So 2 times 45, that would give us 90. All right. The last piece, angles. Let's come take a look. So in the picture, we know that the diagonals are perpendicular. So these are 4 right angles in the middle. And then if I look, I've got this angle up top and this angle here. Those 3 angles, my right angle and then these 2, form a triangle together, which means that they add up to 180. Right? So I can take those 3, so 90, and then plus 5y minus 2, plus 9y plus 8, and set them equal to 180. Or we had written ourselves that quick note to say that the 2 acute angles were complementary. That's because if I subtract 90 right now, I would get all of this, which actually, while I'm at it, let me combine some like terms. I would get all of it equal to 90. All right, so that's the complementary part. But let's get moving on this. 5y and 9y would give me 14y. And then plus 6. And then we can solve. If we subtract, we get 84. Divide by 14. If you grab your calculator, y should come out as 6 there. And then finally, angle TAS. So that little M in front just means measure. So TAS, you're going to plug on in. So 9 times 6 plus 8, that's going to be 54 plus 8 for 62 degrees. Whew, that's a big old question right there. I think that was like a 4-pointer or a 6-pointer off of an old Regents exam. All right, you have one other question here, and that is a multiple choice one. And so I would like you guys to try this one. on your own. So let's make that our post video question. So you're using those rhombus properties to see if you can find the measure of angle DBC. That's this guy right here. All right. We have one last little thing to look at, and that's on the last page here before we hit the next note packet. So flip it on over. With this, it's saying for number 3, you have PQRS is a rhombus. They tell you about the shorter diagonal. Find the length of a side of the rhombus, excuse me. So give yourself a picture. Remember, rhombus means all the sides are the same. So P, Q, R, S. The shorter, oh shoot. This is the shorter diagonal PR. Okay, well guess what? Let me fix these. So I'm going to go P, Q, R, S. So that PR is the shorter diagonal. All right. And now if you have an eraser, erase it. I have white out, so I'm going to, ta-da, like it never happened. All right. So the shorter diagonal is 12. The measure of angle PQR. So PQR right here is 60. Find the length of the side of the rhombus. All right, cool. Well, we know all the sides are the same. So what we just created for ourselves here is a little isosceles triangle. And if that's an isosceles triangle, then these base angles right there should be congruent. So that means if I can call this X and X, those two together plus 60 have to equal 180. So you can create it as an equation, or you could just kind of work backwards and say, okay, 180 minus 60. That would be 120. Chop it in half. Each of those angles has to be 60. All right, well, what does that have to do with the side length? Well, if I have 60, 60, 60, this thing is really an equilateral triangle, which means all the sides are the same. So 12, 12, 12, 12, and 12. So when it says find the length of a side of the rhombus, that would be 12. If they said find the length of the perimeter, you'd have enough to do it as well. Okay, the last thing, jump all the way to the bottom. A square. The square is the properties of both the rhombus and the rectangle. So that's as much as we're going to say about a square right now. So you're taking all those properties, every single thing that we mentioned, and that gets applied to a square. Feel free to add a visual if you like. I'm pretty sure you've known about this visual since you were probably in kindergarten, maybe earlier, but you know, up to you. All right, guys, go answer that post video question from the page prior, and I will see you soon.